This is Algebra 2, Lesson 46 on page 203. So now we're back to radicals. Well, we just worked some radicals, didn't we? By taking the square root. All right, so some of this is going to look familiar. But now it's going to be a little more complex because we're going to have radicals under radicals. So we're going to have double radicals. And we are going to have variables under the radicals. All right, but it starts off pretty easy. All right, so it's 3 square root of 2/7. Look at example 1. Minus 5 square root of 7/2. That part we've seen, right? Our problems stopped at that point. But now we've added 3 square root of 56. So we're going to add these. We want to end up with one term or maybe 2, because one might be a radical, one might be real. But the very first thing I'm going to do is see if I can simplify this radical. Is there a perfect square that goes into 56? 4 goes into 56. How many times? Is it 14? 14. And okay, so it's 2 square root of 14. So I'm going to leave 14 under. We're going to multiply the 2 times 3, which is 6. All right, so I'm going to separate this radical. It's going to look like square root of 2 over square root of 7. You see how I did that? We should be able to go both ways. I should be able to go from here to here and from here back to here. Because in pre-calculus, you're going to have to be able to go from here and see it back this way. Does that make sense? All right, what's my step? What's my next step? Yes, Jaden?
You multiply to another denominator.
Correct. I'm going to rationalize the denominator by multiplying square root of 7 over square root of 7, and this term square root of 2 over square root of 2. So I'm left with 3 square root of 14 over 7 minus 5 square root of 14 over 2 plus 6 square root of 14. I have like radicals. Those are like terms, so I want a common denominator. What's my denominator going to be? Yes, Corinne? 14. So I'm going to multiply this term by 2 over 2, this term by 7 over 7, this term by 14 over 14. And we have 6 square root of 14 over 14 minus 35 square root of 14 over 14 plus, what's 6 times 14? Do it in your mental, do mental math.
84.
84, yes. Now we can add our coefficients. Guys, we do not, okay. A few of you made this error on the test. We started something like this and you ended up with no denominator. All right, I have no equal sign in that original equation. It's an expression. So I'm going to a common denominator. The original equation or expression dictates whether or not I eliminate the denominator. Does that make sense? Do you understand why I'm not eliminating the denominator here? Okay, I'm going to add my positives first and then subtract my negatives. So 84 plus 6 is what? 84 plus 6,
Oh, sorry.
I'm adding my positives, is 90, 90 even. I'm just adding these. 90 minus 35. What's 90 minus 35? 55. Square root of 14. Or you can add your positives, and then subtract your negatives all in one fell swoop. All right, so we're going to add this term in some of your problems. Now we're going to go to double radicals. You always work from the lowest level up. So from the inside out. So if I have the square root of 3, the square root of 3. Actually, the problem is that. This is the second example on the top of page 204. I work under the radical first. So what is this square root of 3? I want to eventually go to all exponents. What's the square root of 3 written as in exponential form, Michael?
3 times 1.
What's that written in exponential form? Just this piece. It's 3 to the
3rd. Wait, what?
What do you mean?
I'm so confused.
exponential form. Okay, do y'all not remember writing these in exponential form? Okay. What does that look like in exponential form? 3 to the 4/5. Remember this? Numerator, denominator. You don't see numbers, but they are assumed to be there. So what's this number? 1. And what's this number?
2.
Oh, no.
Got it? So it's 3 to the 1/2. All right, now I'm going to take this entire term. I could go ahead and combine those. Multiplication is addition. So this really equals the square root of 3 to the what? 1 plus a half, which is 3/2. You're struggling adding them when the base is not a variable? Yes?
How did you get, why do you have 2 3s?
There was a 3 here. I made this equal to 3.5. I left this 3. It's only under this big radical. It's not under the small radical.
I thought that was I thought that 3 was the cube root.
It's not. It would be here. Right?
Sorry.
Do you see I'm marking right there? Yes.
How do you know like what the numbers are that are like 1 and 2?
Okay, good question. Any term is always raised to the first power. If it's nothing is there. If there's nothing in the root, it's always 2. This is always your numerator. That is always your denominator. So, if I had the 10th root of 5 cubed, what would that be, Dylan? 5 to the 3/10, right? Numerator, denominator. Got it? All right. Now, this is not the cube root. This is really, I'll write it a little larger. And I'll write it a little different. 3 times the square root of 3. Makes sense? There's not a dot in there, but look at it in your textbook. Do you see how it's written?
Yes.
I sort of squeezed the 3 in there. All right, so now we have the square root of 3 to the 3/2. So now let's get rid of this radical, and it's going to be 3 to the 3/2 raised to what power? 1/2, right? Because this whole term is to the first power. And it's the square root. You see that? A power raised to a power we. Dylan, you're missing what I'm teaching. A power raised to a power we. So scoot back. Thank you. A power raised to a power we.
Multiply.
Okay, that was so weak. A power raised to a power we.
Multiply.
Okay, so 3/2 times 1/4.
3/4.
So I'm sorry I gave y'all the answer. 3/2 times 1/2.
3/4.
This is the solution. Okay? Make sense?
Yeah.
Okay. Now we're going to change it up a little bit.
3.
Yes. Well, and then we're gonna make it variables and not numbers, but you treat them the same
It's okay.
way, the exact same way. Now we have the big root is a cube root. Yes, yes.
Don't you just do it the same?
Okay, we're gonna do the same exact way. All right, wait just a minute. Nathaniel, which term am I gonna deal with first?
The middle one, the inner middle one.
Which is which one?
Square root of 3.
Square root of 3, all right? What is the square root of 3 written in exponential form? Shh, it's okay.
3 squared. There's 3 square root of 3. 3.
Okay, Nathaniel, you have to understand this. So I want you to focus in right now. The 3 is raised to the first power. It is the square root. Here's your numerator. Here's your denominator. So it's 3 raised to the 1/2. You see that? Now we have like terms. When we have like terms, and they're multiplied, what do we do to their exponents? Multiplication is?
Addition.
So this is then the cube root of 3 to the what? What's 1 plus 1/2? How many halves do we have?
3.
3 halves. Now, Jaden, what are we going to do?
You're going to put it like you're going to take the square root away, and you're going to do 3 halves, and then you're going to do times 1/2.
Raised to the 1/3.
Third.
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 Multiply.
Power raised to a power we multiply. What's 3 halves times 1/3?
3 6.
3 6, which is 1/2. This is 3 to the 1/2. What's 3 to the 1/2 in radical form? It's just the square root of 3. Okay, I just want us to get there. All right.
Okay, I have a question.
Yes.
How did you get from where you had 3 times 3 1/2 to that? How did you get from
Okay, multiplication.
So
When the bases are the same, you add the exponent. So it's 1 plus 1/2, which is 3 halves. Yes?
I still kind of don't understand how you got square root of 3 with the 2 and the 1, and then how'd you get the 2?
Okay.
It's the square root,
The square
so
root
the
is
2,
always-
when there's no number written outside the square root, it's always a 2.
Right.
Because for the square
When
root-
there's no exponent written, what is it always? No, when there's no exponent written, what is it always? It's 1. When there's no root given, how do you always read this? Square root.
Square 2.
But a square has 4 sides.
Square is 2-dimensional.
If I just said square, then you could say 4 sides. That is not what we're doing. We're taking roots. Right? If I just say the word pound, what do you think?
Money.
If I say the word compound, I put something with it, you think something totally different, right? Has different meaning. Square root, okay, is 2. All right? Now let's look at the next one. Now we have the square root of x cubed y squared and the cube root of x y. All right, let's look at the first term. You're going to see the terms under the radical as one single term raised to the exponent. All right, so this is going to be x cubed y squared raised to what exponent?
1/2.
Yes, 1/2. All right, now let's look at the second term. Same thing. The entire term under the radical is going to be raised to the same exponent. So it's xy, and it's going to be raised to what?
1/3.
1/3. A power raised to a power we multiply. All right, so x cubed raised to the 1/2 is x to the,
Seconds.
Because you multiply.
what's
3
3
by
times a
1.
half? It's 3 halves. All right, y squared to the 1/2, it's just y. 2 over 2 is 1. X to the 1/3, y to the 1/3. Am I done?
No.
Why? I can combine like terms. Why can I combine actually like variables? Why can I combine these like variables? Because they are multiplied. Okay, if I had 3x to the 3/2 plus 4x to the 1/3, I cannot combine these. They are not the exact same variable raised to the exact same exponent. And they're added. But when they're multiplied, we follow the rules of exponents. Multiplication is, so this is x to the 3/2 plus 1/3, and this is y to the 1 plus 1/3. I want a common denominator. What's going to be my common denominator? 6. So I'm going to multiply this by 3 over 3, and this by 2 over 2, and I have x 9/6 plus 2/6. What's 9/6 plus 2/6? 11/6. What's 1 1/3 more? 4/3. This will be your final answer. If I ended up with x to the 12/6, then what would I write?
2.
X squared, right? All right, let's look at the last example. Let's look at the last example. So cube root of x to the 5th y cubed and the 4th root of x y to the 5th. All right, Dylan, what am I going to do first?
Everything underneath the radical is to the power of 1. And then
Wait, just a minute. It's to what power?
1. Well, 1/3.
Correct, 1/3. You're right, everything under the radical is to the first power, yes. All right, what about this second term?
It's the same thing, but to the 1/4.
Michael, what do I do next?
Next up, you multiply your exponents by the exponent on the outside of the parentheses.
All right, so what do I end up with in this first term?
X 5/3
Yes,
times y just y.
right. And Ashley, what do I end up with this second term?
It'd be x and 1/4, and then y and 5/4.
Yes. And then Corinne, what am I going to do next?
And you're gonna combine your like variables.
Yes, good job. So I'm going to end with x to the 5/3 plus 1/4. Okay, guys, this is important because we're going to eventually have binomials up here in the exponent place. Binomials, like 2x plus 1. And we're going to have variables. All right, but the rules do not change. The rules do not change. All right, and this is going to be y to the 1 plus 5/4. So what's going to be my common denominator? Yes? 12. So I'm going to multiply this one by 4 over 4, this one by 3 over 3. Nora, you get my exponent for x.
It's
23/12. And what's the exponent for y, Jake? 9/4. All right, same rules, feels a little more complex, right? Adding some more layers of math.